Hello, students. This is a Smart Kids Learning Center class. This is our contact number for online class. And we majorly tutoring all the high school math and specific for grade 12 advanced function, calculus, as well as English and all school homework. And please book the first free online class. And today we are going to continue the chapter 1 test. So in this textbook, Advanced Function Grade 12 for Hill-Ryerson. So if you have the same textbook, open to the page 78 for unit chapter 1 test. But if you have used the other textbook, all the textbook have the same concept for grade 12 advanced function. So you can learn the knowledge and skill apply for your study. Now let's start the part 2 of chapter 1 test for from question 9 to 13. Let's look at the chapter 1 practice test. We continue for the part 2 of the test is question 9. So question 9 is transformation applied to a y equal x exponent 3 to obtain the graph shown here. We're going to find the equation. So first, we identify the vertex C. The vertex C x is a 3. And y is a -5. So, and then we're going to write here. So 3 and -5. And you know, this is the end behavior is opposite. And we know it's an odd function, an odd degree function. So for odd degree, so we're going to have neither, this is x, y equal x exponent 3. So we are going to write the equation. And this equation, you know, it has been shifted. So x is 3 units. So if you go back to the original, this vertex C point will be at the origin. And you can see the graph should be rise from the second quadrant to the fourth quadrant. So therefore, it's a negative leading. So we're going to write the parental function first. It's y equal x exponent 3. So the one has been transformed. Y equal negative. So let's say we put a -2 approximate by the graph. And you're going to put bracket. So x, the vertex C, -3, exponent 3, and -5. That's the equation for question 9. Now, we are going to do the next question. Now, next question is question 10. Describe a real-life situation that corresponding to A, a constant positive average rate of change. So when is a positive slope? You can write an example like a speed for 100 km per hour. So it's a perfect example, positive slope. And B, it's going to be for a constant negative rate of change. So we're going to find a negative slope. So you can put like for a temperature, let's say -5 Celsius, instructed by hourly. So this is temperature negative illustrate the negative slope. Numbers, we can write the acceleration. So any acceleration speed, it will be constantly change. I mean non-constantly change. Good. Number D, a zero average rate of change. It means zero rate, the slope equals 0. So that's going to be no change. It's a horizontal line. So what can be illustrate a horizontal line? For example, no change in the revenue. So these are the examples for the question 10 to answer. Let's do the next one. Now, question 11. The question is, in 1990, 15.5% of the household had a CD player, and why 76.5% of the household had the CD at the 2003. Now, what the question is asking, determine the average rate of change for the percentage of the household. So by the information given, so X is the time, we write the first point. The percentage is 15.5%. The second point, the year, is 2003. The percentage is 76.1%. So we're going to find the average slope. So we apply the slope equation. Y2 over subtract Y1, 76.1 minus 15.5. And we're going to get 2003 subtract 1,990. So what are we going to get here? So you can continue. So it's going to be 16.6 divided 13. And you're going to get, so the answer will be here, equal 4. So I move the paper a little bit, 4.66%. So the unit is a percent. So per year, so yearly. And that's the slope for answer question 11. Now we are going to do the next one. For question 12, so an oil tank is being drained. The volume for V in liter, and the oil remain in the tank after T minutes. So it's going to be for this function. So V at the T equal 0.2. So we're going to write the equation. So V at the T, so it's equal 0.2 times 25 minus T exponent 3. Now, which interval are we looking for? So the interval for T, the T is equal from 0 to 25. 0 minute to 25 minutes. That's the interval we are looking for. We first solve for A. How much oil is in the tank initially? So initially means when the time being 0. So what is the volume? So we put V as 0 is equal 0.2 and 25 minus 0 exponent 3. So you use the calculator plug in. So you're going to get is equal 3,125 liter. So that's for A. Now for B. So what B is asking, determine the average rate of change for the volume. The first one, first 10 minutes. The second one, the last 10 minutes. So we're going to do B here. Let's do the one for first 10 minutes. So for the first 10 minutes, it means there's 2 points. So the first point we already done here. So it's when x equals 0, y equals 3.12. So we apply the slope. So the first 10 seconds, we're going to plug in 10. So 0.2 times 25 minus 10 exponent 3. And subtract the beginning, initial. We got the y2 here already. It's 3,125. So we're going to use the time 10 minus 0. So what are we going to do? Use your calculator. So you should be able to get 675 minus 3,125 over 10. So the slope is equal negative 245 L per minute. So that's the slope for the I. The next one, for the second one, looking for the last 10 minutes. So the last 10 minutes, you look at the interval from 0 to 25. So therefore, you are going to get, if you use the number line, so the time interval, so from 1, so and then from here will be 15, and from here will be 25. So therefore, the last minute is going to be 15 and 25. It's called the last 10 minutes. We're going to apply these 2 points to find the slope for the t. So this is a t equal. So the slope will be equal. The first one with substitution for 20, 25. So you're going to put 0.2 times 25 minus 25 when t equal 25 exponent 3. So, and then subtract. The next interval, the point is 15. So you're going to put 0.2 times 25 minus 15 exponent 3. Now the time interval will be 25 minus 15. Now when you plug in your calculator, so what are you going to get? So for the first one, so if 25 minus 25 equals 0, so you have a 0. So 0 minus, the second one is plug in for a 15, you get 200. Now, and then 25 minus 15, you're going to get a positive 10. So it's going to be equal negative 20 liters per minute. So that's for the slope. For the B, so we get the one for the first 10 minutes and the next one for the last 10 minutes. And that's how you get the time interval to find the slope. Now, we are going to find C. Compare the variable. You find it and the B. Explain any similarity or difference. So we're going to explain it for a C. Now, how are we going to explain for a C? Now, by the B, we get 2 negative slopes. So we're going to explain. So the average slope are negative. So they are negative slope. So apply to drain out the oil. So that's how we explain it. And that's for the question 12. So we're going to plot question 12D. So when the time being 0, the y-intercept 3,125 L. And also for a t-intercept when it's and then we move on for the E. So question E for question 12. What does the variable of fun in part B represent of the graph? And these are the slope of the secant. So we finish the question 12. We are going to do. Now we are in the last question. The last question is giving you the equation for D and T. So it's equal 0.002 T exponent 3 plus 0.05 T squared plus 0.3 T. Now you find the unit. T is the time in second. So A. Determine the average rate of change for the distance traveled during the first 10 seconds after leaving the shore. And B, estimate the instantaneous rate of change after 10 seconds. And C, you're going to explain A and B. Now, let's start to work on. Now, we're going to find the slope for the first 10 seconds. So the first one, when t equals 0, you plug inside the equation, y equals 0. The second one, when t equals 10 seconds, you plug in t equals 10. You get the value for 10. Now we got 2 points to find the slope. So the first one is going to be m is 10 minus 0. And also 10 minus 0. And because the point is 0 and 0, and 10 at 10. So, and then we find the value. When you're going to divide, it's equal 1 second. So we're going to find 1 second for the equation. The distance is traveled in meter. So we have to write the meter per m. So that's the first slope. Now the B. So we're going to find instantaneous slope. So that's for A. Now we're going to do B. So B is going to be with the first point for 10. The point is 10 at the 10. Now the second point, we're going to plug in 10.1 instantaneous slope. So when it's 10.1, what are we going to get? We're going to get the point will be 10.1911. So if you substitution, so you're going to put m is equal, so y2 minus y1, 10.1911 subtract 10. So over 10.1 minus 10. So what are we going to get? So, and the slope will be equal 0.1911 divided 0.1. So it's equal 1.9 second per m. So that's how we find the instantaneous slope. So use a tiny difference in the time. So plug in, you get the y2 and you get the slope. It's very close for 1 point. Now we're going to find C. So how do you explain C for A and a B? So you're going to find all the slope are positive. So you're going to write speed is increasing for all positive slope. That's how we do question 13. So find every slope, instantaneous slope, analysis the slope. And now we are complete all the equation. in Chapter 1 test. So Chapter 1 practice test, we done everything. Great. Now we successfully complete the Chapter 1 test. Please, apply for your study for Chapter 1 Polynomial Function. And this is our Smart Kids Learning Center tutoring class for our contact number online class. And please book for the first online class free. And please subscribe to join our class study. Thank you. I'm going to see you in the next video for Chapter 2. Bye-bye.